and I am a MuleSoft mentor as well, certified developer and architect. And recently I joined the episode as a solution architect. And yeah, that's all. Over to you, Anu.
Yep, thank you so much, Ashish. So myself, Anu Pramachandran. So I'm working as an integration architect at NJC Labs, and also as a technical instructor outsourced to MuleSoft. So my primary um, teachings are based on production-ready development courses, fundamentals I teach, and other than that, so these are my experiences. Yeah, so that's pretty much about me. Um, yeah, I'll give over to you, Balkis.
Yes. Hi everyone, thanks for joining here. So this is Balkis. I have a total 4 plus years of experience in MuleSoft, currently working as a solution consultant at Pizarro. I'm a certified developer and recently completed my MCA too. Yes, that's all about me. Thanks everyone for joining. Thanks because for giving the wonderful sections. Over to you please.
Sure. Yep. Thanks, Balkis. Thanks, Balkis. So here is our instructor, Vikas. So I'll let Vikas to introduce him. Hi,
So,
Vikas.
yeah, hi, Anu. Hello, everyone. Myself, Vikas. I'm having total 11 years of experience in IT, out of which 10 years of experience I'm having like full stack developer. And from last 1 year, I'm working in integration domain. I am MuleSoft certified integration architect, platform architect, as well as MuleSoft certified developer. Apart from this, I'm also Google certified TensorFlow developer and Oracle certified Java professional. So this is a bit about me. Thank you.
Yep, sure. Thank you so much, Vikas. Thank you for joining in the session. So let me move on to the next slide. Give me a second. So a couple of things. So a safe harbor statement. So we are as a MuleSoft organizer and a speaker. We are not representing any company or here. So we are working as an individual here. So that's one thing that we want to point it out. And the other thing is presentation is strictly for learning purpose. So at any point we are not promoting the product, or we are not here to sell sales domain here, sales kind of work. Okay, so that's a few things to remember. And yep, so at the end of this we have a trivia quiz. We'll be having the Kahoot things going on. So so 3 people will be able to win the special prize. So requesting you all to stay till the end. Yep, so with that I'm handing over the presentations to Vikas. So he'll taking over from here. Vikas, over to you.
Yes, thank you.
I've stopped sharing.
Yes, I'm sharing my screen now. So, Anup, my screen is visible?
Yes, your screen is visible. Yeah.
Yes, Vikas. Yeah.
Okay, fine. Thanks. So, guys, today our agenda in this meetup is to go through some of the Einstein points, like Einstein API, like capabilities of Einstein APIs. It is having capability of NLP and computer vision. So we will also go through the basic concepts of NLP and computer vision. I've also written some machine learning program for one of the NLP program, and then we will see how Einstein API endpoints will replace the actual implementation of NLP. So just with the help of some endpoints, we will be able to train our model and do the predictions. Okay. So let us start with the Einstein API. So what is Einstein API? Like Einstein API itself, like Einstein suggests that it is related to some intelligence stuff, right? So Einstein API is provided by the Salesforce for language services and computer vision. Language services in the sense natural language processing, right? So this is an intelligent API provided by the Salesforce. So before deep diving into the endpoints of Einstein API, let us go through the basic concept of NLP and computer vision. So here, what is like natural language processing? It is, as the name suggests, right? It is a processing of natural meaningful information from natural languages. Natural languages can be anything like English, Spanish, Hindi, Chinese, Japanese, any natural language, but not like Java and Python. Those comes under technical languages. Okay. So what are the applications of NLP? NLP is almost used in most of the fields. Like you can say sentiment analysis, right? Suppose we are having some movie reviews. With the help of NLP, we can easily predict whether this review is good or bad about movie, right? Topic modeling is one of the other section. Like if we are given some topic or we are given some document, right, and we want to classify that document into some of the topics, then NLP is generation or recommendation, we can say. That is also one of the good example of NLP. Like nowadays there are a lot of extensions coming with like Visual Studio, right? We just type the code and auto suggestion will happen. That is the example of NLP. Is also example of NLP. You just need to write a comment and the code will be there for you. That is also a good example of NLP. So in this slide, like I'm showing you the phases of NLP in order to develop any NLP program, but I'm not deep diving into each and everything. What is like stemming, lemmatization, backward, and all. On a very high level, we'll go through that. So the very first stage of any machine learning program is you should have some data set, right? So the first stage will be, after that it will be a processing, right? Pre-processing is like cleaning of the data. Basically you need to clean the data before you need to provide that data to machine learning model. And in NLP, the cleaning includes like removing of punctuation, converting that to numeric form. This will come to know later on slides. After that, clean data will be provided to the model, and that will be the third stage, right? To train the model. After that, it comes the fourth, which will be a evaluation of the model and the prediction of the model, means prediction of the contents. So before deep diving, let us go through the one of the program which I have made for NLP part. Okay, so this weather CSV file is provided by the Einstein API, which will have some weather data, and the same program we will check with the help of Einstein API endpoint also, so that we will see the comparison, how easy that and Einstein API make our work for machine learning. So the very first step is construct the data set. Here what we are doing is we are just getting the data from this weather.csv, right? Data zeros and ones, and let us replace this 0 and 1 with intent and label. So now this became our intent and this is our label, right? So whenever we will be having some intent, we need to predict its label. So here, if you will see, we are having only three labels. One is current weather, other one is 5-day forecast, and the third one is hourly forecast. So whatever intent we will give, it will fall under one of this label. Okay, so like here it is written like what's the weather look like. So by just reading this context, we can come to know like we are asking about the current weather. So the probability of current weather will be more in this case. Okay, so then comes the pre-processing. In pre-processing, I have done the very basic part. I've not implemented it in complete way. So it is just a lowering of text, removing punctuation, stop words, and all. So this is done. And the second most important part is like machine learning model won't understand this text part, right? So this text part also we need to convert into numeric forms like numbers. We need to give that. So that is documentum matrix. I will not go through documentum matrix. That will be in detail. Okay. So here what we are doing is we are converting this to numbers, and this whether look like this will be converted to number with the help of this code. So overall, we can say that second step is related to pre-processing. Then the third step will be our training of the model. Okay. So in the training of the model, what we are doing is we have got our clean context from the clean data from the previous stage, and from the previous stage the clean data will be provided to the model and it will get trained. And here I have used the very basic model. I have not used the later on. And the fourth one will be your prediction or evaluation, where you can go through scores, accuracy score you can get, recall, precision, F1 score. There are a lot of evaluation metrics, performance metrics you can go through. Okay, so these four are the major steps involved in any machine learning part, and it is particular for this NLP. So now let us see how Einstein API made it easy for us.
Sure. Because I had a doubt. So on a high
Mhm.
level, so these are the steps for any machine learning program that we use it to construct an API or a.
So Anup, okay, actually the processes will be same, but the thing is what you are doing inside this processing, right? So the second
Okay.
step is like pre-processing, right? So for NLP part, as it is language related, we can remove punctuation, stop words, and other things, right? But for computer vision, it will be different, right? We need to scale the image, right? Maybe the image scaling will be more, we need to scale that image, or the image data will be less, right? So we need to provide some image augmentation. Image augmentation can be, you can say, like suppose we are having very less images of like 1,000, and what we need to do is, in order to train the data, we should have more images, only then we will get the more accuracy. So image augmentation will happen like images will get flipped, right, horizontal to vertical, then there may be rotation and all, get more images.
Hmm.
So
Okay.
but the basic is same. First of all, you need to get the data, then you need to do feature engineering. Feature engineering is like cleaning the data, right, handling missing values, feature selection. After that you need to provide that remove this outliers and all. Okay, after that you need to provide this data to any training of the model. Okay, once the model get trained, you need to evaluate it performance. Okay, evaluation can be with the help of, for evaluation there is one classification. Maybe you can go through this classification matrix. So maybe you can go through this. There are some classification performance matrices part.
Okay.
So
Yeah.
everything
I
same
will
there.
go through that. So we have a couple of questions here from what is from one
Mhm.
Mr. Chetan. What is intent?
Intent is the text which you will be providing over here. This thing,
Hmm. Okay.
yeah, and this is label. With this intent, you need to predict this label.
Okay.
Okay.
So we are providing some random text there, and we are mapping
Yes.
it to that way
Yes. Yes.
current weather. Okay.
Yes. Yes. This is just I named it. You can name it as any XYZ or anything, right? This I have
Yeah.
just named it. Okay. Intent and label. So this is basically our labels. Label can be our output features. Means okay, output labels. In machine learning, we can define it as output label or anything, right? Dependent variable, and this one is your like independent variable features. Okay,
Hmm.
with this
Okay.
we need to predict this current weather or 5-day forecast, hourly forecast.
Okay. Okay. Cool. So we have
Okay.
question from Lalit. What is the overall context of this program? Okay, so I will take that question because so Lalit, like what we are trying to explain here is, so it's all when you compare this API, Einstein APIs to MuleSoft, it's all a request component, sample request, and then you are getting a response back. That's it. But what Vikas is trying to make us understand is what is the working of that particular API inside that, how they have returned that API to us. So that's what he has tried to reproduce it and showing us what could be the output. Do you have anything to add, Vikas?
No, that is what I mean. Like we are after this going through this program, we will see how Einstein API makes us easy. Like we just how these phases are replaced by which endpoints of
Yeah.
Einstein API.
Exactly. Yeah.
Program, then it will be easy for us to understand the Einstein API endpoints.
Yeah. Yeah. That's it. Yeah. Yeah. I think we can move on. Yeah. Sure. Yeah.
Okay. So this training and this predict intent is done. So now we are good to go with Einstein API part. So let us start with the demo. So first of all, for Einstein API, we should have the account of Einstein, right? So in order to create the account, this URL is mentioned over here, right? You need to go, actually for now, I have created the account initially, otherwise it will take like maybe 3-4 minutes. So I have taken it, I mean, like I have already created this account. So you just need to follow these steps. Einstein group sign up. After that, you need to sign up with Salesforce, right? Everything is there. Einstein platform. Actually, this is the main step. Like you need to download this key, and with the help of this key only, you will get the BRA token. Okay. So you just need to download this key. After that, this is our one of the URL. You just need to enter your email or account ID, which you have created here in the previous tab. Okay, these steps. And after that, the key which we got from this step, this key, right? This step, this key you need to upload here, right? After that, here you can give the expiration time and get token, and this token you will get, and this you can further utilize while calling the Einstein APIs. This is very basic step. You just follow this thing, right? The URL is mentioned here. So if we will see about the MuleSoft integration with Einstein, there is not much about to do with the MuleSoft integration. Just we have used the HTTP request connector. And with the help of HTTP request connector, we are just calling the URL and passing the payload and all. So I have already done this and deployed the code to the cloud. So we will be directly using that. So let us go through the endpoints. So here, if we see in our machine learning program, the very first step is we need to construct the data, right? So now Einstein endpoint, and this is the language APIs. We don't need to go for Vision as of now. Now here they have provided us two APIs. One is create dataset asynchronously, other one is synchronously. Okay, this will do the same work of this construction of dataset. Okay, so let us go here. I have taken this, and here you can provide the path. This is that API. I have done that in advance because it will training of the model may take like 5 to 10 minutes. So I've done that in advance. So this is the API. After that, you need to provide here authorization token. After authorization token, in this path, you need to have this URL. Okay, where exactly in remote location your file is. If your file is in some local drive, then instead of this path, right, you need to give it as data, and you can refer that file. Once you send this, then you will get responses like ID, data, and other fields. So this is basically our ID. It will tell any machine learning model, means like program, that you can train model in on this ID, right? And this ID is the location of our data set. Okay, so our first part is done. And the second part is our pre-processing.
Because sorry to interrupt
Yes.
here. So the API that you are showing is a Cloud Hub published API, isn't it?
This is my local. Actually, I have implemented the same program, right, in Cloud Hub. This
Okay.
Einstein API, if you will see, Einstein API Demo USE2. This is my Anypoint platform account.
Yeah. Okay. Okay. Fine.
Okay. So this is done here. But on like, if you will say for MuleSoft side, we just need to have HTTP request connector. And with the help of HTTP request connector, we can have this URL, this
Okay.
Einstein
So
API endpoints we can have. Yes.
Okay, the Cloud Hub API internally calls that Einstein API and gets the data
Yes,
for you.
yes, yes, yes. It is
Okay.
calling this APIs,
Okay,
right?
fine. So, and
Like
what data it is returning?
it is returning everything, means like the dataset ID, right? We'll see. I will show you. Look, it is returning that name, dataset ID,
Okay.
updated at this label. So it's a message uploading all right. So not synchronous
Hmm.
call. So it will upload that on the backend. If we upload it, okay.
Okay.
So which language it
So
is? By
you are
default, it is
currently
US only. Yeah. Right.
okay, fine. So using this API, you are currently training the model.
Yes,
Okay,
yes.
cool.
You
Okay, so
training the
one
model.
question we have.
Not training the model. Sorry, no. Sorry to interrupt. We are not the model using this API. We are just, as of now, this is very first, right? In cloud, there should be some location where this data set. Are you
Okay.
getting me? Let me go through this. Look here. See, the first step is to get the data set, right? The model should know the data set, right?
Okay. Okay. So
Yeah.
got it. Got it.
Yeah.
Yeah.
This is the first.
So okay, instead of a CSV file, we have our cloud system.
We are. This is CSV file only. We are getting it from a remote
Okay.
path, similar to this, right? Here also we are
Okay.
getting
Okay.
from. This is a
Okay.
remote
Fine.
location. If you are
So
having local location, then you can have here data, key as data, and you can browse to local computer location, right? But the only size limit, it is having size limit drawback. If you see here,
hmm,
you know, it should be something like 20 MB, or if we are having text intent, the label, each label, like it is like multi-class classification, right? We are having 3 label, so each label should have at least 20 data, right? 20 examples.
okay.
Yes.
Okay. Okay. Fine. So we have one question from Lalit again.
Mhm.
So are we calling weather API and then sending data to Salesforce API? No, right? We are not doing
What?
that.
No, no, we are not calling the weather API. We are just calling this. Look, our CSV file can be anywhere, right? If we will open here, I don't know whether it will get open or not. This is a location of CSV file. You can put it anywhere, right? Maybe in any part you can get it. It got
Sure.
downloaded,
Sure.
right? If you will see here, it got downloaded. Weather CSV, right?
Yeah. Yeah.
So
Give
this.
me a second. Let me unmute. Um, Lalit. So he wants to have a word. Let me check. Give me a second.
Mhm.
Um, yep. Lalit, I have given you the presenter
Yeah,
access.
yeah. Can you hear me now?
Yes,
Yes, yes.
Lalit. Go ahead.
Yeah, so basically, I'm not able to follow. I mean, those 4 steps we got it, like creation of data set, cleaning data, modeling, training the model, evaluation. Those 4 steps we get, but I'm not getting. Is it you have created a data set beforehand in the form of a file? You are picking it up using a Mule API, which is deployed cloud, when you are sending the data to the Einstein, Salesforce Einstein
Okay,
module.
okay,
So that flow is we are not able to understand the flow. At least I'm not able. I don't know about the others, but I'm not able to understand the flow from where it is starting and where is the
okay,
end, and then how you are evaluating, or what
okay,
is it?
okay, okay. I will go through this. Look, the very first flow is you need to construct the data set. For this, we need to have some data, right? Initially, we should have some data, and it depends upon the location. This we can have some local location, but here it is not local location. It is in remote location, right? this is just a path, you can say.
Okay, yeah, that's fine. So this is basically the data. So can you show us the data? What is this data?
Okay,
Is
I
it
will show
possible?
you. This is here you can see, right?
It is the same.
Oh, yes, this is that data. It is the head, means first 5 rows of this data.
Okay, so it has basically two columns. One, these are the two columns in this data
Yes,
set.
one is like this thing, and this. The second column is for prediction, like current weather. It is having 3 labels. You can see here, right? Current weather, 5-day forecast, and hourly forecast.
Okay.
It comes under this column. So whatever content we will give first, we need to predict that. So this is, you can say, training data we are having, right? Initially, like in machine learning, we should have some training data. This is the type of supervised machine learning, right? We are having this training data, and so in future, whatever comes similar to that, it can predict that, right? Because in future, this second label won't be given. Second label we need to predict.
Okay. Okay. Once you have that data, so what you are doing next is?
Once we are having this data, we need to pre-process this. Look, because if you will give the data as it is to the model, then the model will not show the accuracy, right? It won't do the good accurate, means like good predictions. For that, we should give the model the clean data, right? The very first step of cleaning, you can say, like model will not understand this text at all. It won't understand. Machine learning model won't work on text. It will only understand numbers, right? Numeric 1, 2, 3, 4, 11, whatever, right? It only understand numeric part. It won't understand your text part. So in this pre-processing, also we will convert these to numbers, right? We will assign each thing. Look, if you will see here, if you want me to go through this as well, I will tell you. Suppose we are having this text, right? So what it will do is, in pre-processing, look, this apostrophes doesn't make any sense, right? We can remove this. This is one of the steps we can do. After that, you can say that these are the stop words: is, a, the, are, right? So we need to remove these stop words also. Okay. Then now this looks like stemming and lemmatization is there. So I'm not going into that detailed steps. Okay. So what it will do is, now let's machine learning will give this as suppose 5, right? Then weather as maybe 2, okay, or like suppose 1. Okay, this number it will allocate in pre-processing. Look as 2, okay, or 3. So what we will do is, what's is 5, okay, then weather is, after weather it's 2, and look is like 3, and like is 1. Okay, it will provide in this sequence, text to sequence, you can say. So this words will be same over here. What's the temperature? So here what's also means 5. Are you getting me? It will assign each word as one number, which will be common in complete data.
Okay.
Are you getting me?
Yeah. After that, so basically, whatever string we are providing, that whole sentence, it is basically broken into individual strings, and every string is assigned a numeric value or number.
Yes. No, you are getting
So,
me. So
Lalit, what happens here is when we search for a string, for example, when we search for what's the temperature, then machine learning is going to attribute that particular sentence to the current weather. Then it will give the probability of that current weather to us. Got it. So that's why we are training this system to understand it better. So here we used a 0 to 4. Each sentence is attributed to the current weather thing. So when we are going to search, with some words like what's current temperature, then it is going to attribute that particular sentence to the current weather. Then it will give you the probability of that particular weather.
Suppose I will tell you. I'm showing you in advance this. Suppose here I have written that what's the weather after 5 days. Okay. So here these three are the label, right? So the probability will be more for 5 days forecast. Here it is showing 39% of chances I'm asking about next 5 day weather, and there is only 30% of chances that I'm asking of overly forecast and 30 about current weather. So similarly, if here I will write what okay what's the weather now. So let us see the probability. It depends. Probability actually this totally depends upon the data, right? Here also, current weather probability is now increased to 35%, right? And maybe we don't have that much sufficient data from Einstein. That's why it is not showing that much accurate. So if I am writing what's the current weather, okay, so it is showing 58% are the chances that I'm asking what the current weather. Hourly forecast is 23%, and 5 day forecast is 0.17%.
So basically, depends upon how much bigger your data set is, and so definition of your data set and how the bigger coverage you have.
Yes, actually, it
Yeah,
depends.
exactly.
It totally depend upon the data set, how much bigger data set we are having, and how much quality that data set is having. It's always not
Yeah.
like that. If we have a bigger data set and it is not having the quality, it will give them more accuracy. For giving them more accuracy, we should have quality data set, right? Everything
Yeah, I
should
mean,
be
yeah.
trained at
Basically,
that.
I
Yes,
was saying coverage. Yeah, it is
yes,
quality.
yes, yes, yes.
Yeah.
So Lalit, now am I clear?
Yeah.
Okay. After that, just training, and training. It is like I have not used TensorFlow and all for this the complex part. Just for this Einstein API, I have just used the very simple model, right? So just in order to tell you guys like which step is replaced by what endpoint for Einstein API. That's it.
Okay. Yeah.
Okay. Any other
Looks
questions?
good. Yeah.
Once we have this data, right? So where you sending it to the Einstein module, this data set, whatever you have,
This is
you know.
mm, okay. I'm not sending it anywhere. This is the complete part written by me. Einstein is doing everything on its own, right? On the back end.
Okay.
Maybe Einstein is not using multinomial, and maybe it is using some other naive Bayes or some other model, logistic function or anything, TensorFlow. It may use some different model, but the steps are same. It will be following. It will replace this with its own implementation.
Okay.
Am I clear, Lalit?
Yeah.
Yeah. Little bit. I am still not fully clear. Basically, what is the role of when you say Einstein API? What is that API? Is it a Salesforce
It is
API?
yes. It is a API provided by Salesforce for
Okay.
having natural language capabilities. You can say here it
Okay.
is providing the vision part as well as this language services.
So what
Okay.
is that API doing?
Sorry.
What is this API doing for your data set, or for what you are using this API?
API I'm using for this complete machine learning part. That is
Okay.
what I'm telling you, right? Whatever I am doing here,
Mm-hmm.
we are having endpoints. It will do the
Okay.
same work what I
Okay.
have written here. So no need to write this much of code, right?
Okay.
With just 3 endpoints, you will do everything.
Okay.
Okay, so it makes our works easy, right?
Okay.
We do not need to write everything over there. Just we need to have this endpoint. We don't need to have any knowledge about what is count, vectorization, fit transfer. We don't need to have this knowledge. Just a low code part. Just you need to hit those APIs and your work will be done.
Yeah. So that's what I explained you first. What Vikas is trying to do is to explain what is inside that particular API. So for us, as far MuleSoft is concerned, it's just about calling a request, using a request component, calling that endpoint. That's it. But so only if you understand the inner working of that, we can able to use that APIs effectively. So that's what Vikas is trying to explain here.
Okay.
Thanks. Any other questions?
Yeah, so we have one question from Victor. What is the data relation? How you construct the data?
Construct the data in the sense how we got the
Maybe
data. Yeah, this
data
one.
set. Maybe I think data set.
Yeah, data. This actually. This data set I am getting from Einstein API, right? Einstein API is also working on this data set only as of now, right? But we can replace this data set with any other data set as well. So this is just an example of weather CSV data set, but we can replace it with some other data set having multi-class classification, right?
Okay, cool. So do we have to create any other API for that?
No,
Or we
no.
just need
You don't. You just need to give the path over here. It will do
path
your.
over here. Okay.
Yes, you just need to provide here that path CSV file.
Okay, for the Einstein API, we just need to provide the path, and it will actually create
Yes,
the data set for you.
yes. It will create the data set. This is a data set only, right?
Yeah.
Yeah.
Okay. Okay, got it. Yeah.
So after that, our data set is now there. So we should go for the training of the model, pre-processing and training, right? Which is our second and third step. Second step is pre-processing, and third step is training. So Einstein model is not providing a separate, endpoint for pre-processing. What it is doing is, whenever we are providing the training, when we are doing the training of the model on the back side, it is also doing the pre-processing as well. Okay, so we are having this part. Train of the data set is there. This API is provided. So if you will see here, okay, this is Vision. We don't need to go for Vision as of now. This is NLP. Okay, so let us go here. Now we are having this ID. Just we need to copy this ID, and while training the model, we need to provide this ID in the dataset field, because only then the model will come to know on which part, on which data we need to train it, right? I need to train, I need to process. So this is the ID you need to provide.
Okay.
After that, the status will come as queued because it is asynchronous. It won't means like do everything. So just status is queued. Now you need to wait until it is get trained, right? It won't train immediately. It will take at least 3-4 minutes, because at the back end there will be many steps going on, pre-processing and all. So the Einstein API also provided this get training status API endpoint. So what you need to do is, this model status you need to know, right? So you need to copy this model ID, and in this you need to provide this model ID. So it will tell you the status. It is now succeeded, right? So means this I have already done for you, because it will take 5-10 minutes. So initially I have done this. So now it is showing that status is succeeded, means now your model are ready for predictions and all. Use our model. Okay. After step will be your evaluation. Okay. This evaluation is your matrix evaluation, right? So you can do evaluation. The model ID you need to provide, and based upon that model ID, you will get all the metrics data: F1 score, labels, recall, right? Precision, test accuracy, training loss, everything. This is like how accurate your model is. This is different parameters by which you can evaluate your model, right? So
Sorry to interrupt. Can you give a little more detail on the evaluation part, or what evaluation is doing?
okay, I will tell you. So the very first part is training is done, right? After that, we need to evaluate the model, whether our model is good enough for prediction or not, right? We should have that idea,
Okay.
right? For that prediction, we are having different part. I mean, it's like different parameters we need to consider. One of them is accuracy. How accurate is your model, right? How precise is your model? That depends upon the confusion matrix. Actually, Anup, I don't want to go in that detail, because I need to explain everything like true positive, true negative and all. everything. But the main stuff is it will just tell you how good your model is for prediction.
Okay.
If on high level will
Okay. Okay.
you can go through this
Cool.
part.
Cool.
It is having this parameter. Everything is explained here. It's confusion and recurrent
Okay.
precision recall efforts go right. So
Fine. Fine. So we have a subsequent question from Vivek. So will
Mhm.
accuracy depend on number of times we train the model with the same data set? Mm,
Accuracy, no. Can you please come again? This question.
will accuracy depend on number of times we train the model with the same data set?
No, accuracy is not like that. We should have quality data set, right? If we are training the data set again and again, it will anyhow make it more accurate. But the thing is, it is not generalized, right? It won't predict the future thing, right? In order to predict the future part, right, the unseen data, you can say, we should have more data to predict. It is not like that if we will be predicting, training the model again and again on the same thing, it will give more accuracy. For that, there is some hyper parameter tuning we need to do in order to make our model well performed.
Mm,
We need to perform a lot of hyper tuning.
okay. Okay. So basically, like we do for the robots, like we train them or inject them with lot of data so that they understand things well.
So
Right?
that is okay. I will tell you that part. What he's saying is epochs, right? There is one parameter, epochs. You can mention here. This is that parameter, epochs. Number of iteration we need to do, right? You can iterate the model again and again so that this is
Okay.
what I think he's asking. Okay.
I'm not sure.
Yes, it will be a number
Okay.
of training iteration. It will iterate if whatever you will mention here, it will iterate through that model. Suppose you mention 100, right? So it will iterate through the same data again and again, which will increase its accuracy.
Yeah. Okay. Cool.
Hmm.
Makes sense.
Yeah, we need to actually iterate it, but it depends, right?
Okay. So by evaluating, we'll give that metrics of how much accurate your
Yes,
system
yes,
is. Right? Okay.
yes. There are different parameters for evaluation also. Like suppose we are having imbalanced data set, right? You can say imbalanced data set like here we are having three classes. Okay, here we are having three classes. Okay, and each will be having equivalent distribution. And suppose if okay, let us make it easy. Suppose we are having these two classes. Okay, and suppose here in current weather we are having almost 19 total 100 records we are having, and it is divided among current weather and 5-day forecast. And for current weather I am having 99 records. Okay, and for 5-day forecast I am having only one record as of now. So our accuracy will definitely be more. If we will predict always current weather, it will be more. So their accuracy matrix parameter doesn't make sense. So there comes the role of precision. So actually there are a lot of evaluation criteria, right? Evaluation metrics we need to consider.
Okay.
Yeah,
Okay.
sometimes
But
accuracy matter recall, sometimes other thing, right? It depends actually.
okay. Okay. But Salesforce gives us an API to in order to
Yes.
look into
Sales,
look into that.
yes. Salesforce gave us API. This is that API. You just need to provide this, and you can see here metrics data, F1, label, recall, and then you have to analyze your own, right? Which thing you need
Mm,
to consider. Test accuracy is this much, loss is this much, confusion matrix is this. Now you need to consider whether this is okay or not. Training accuracy is, you can say, 98% it is showing. Okay.
okay.
So now it's up to you, right? They provided you everything. Now it is up to you whether okay or
Whether to
not.
use it or not.
Yeah.
Okay. So we have one more question again from Victor. Where is that data for step in 5? Where is that data for step in 5?
Step in 5. Step.
Uh, In 5, I think it's now you're showing 10. Can you go to the top?
This.
Yeah, it's in 5. Yeah, so you might be asking how these things. I think it's from the Excel, isn't it?
This is from the Excel only. This is this thing. Here actually I'm only head will only show this. Let me run it.
If you can open that Excel, that will be great. I think. Do we have that
Actually,
Excel with us? Okay.
actually my Excel is corrupted, so I don't know whether it will open or not from here. Let me try. Excel is corrupted, but I can show him. I can show him from here as well.
Yeah.
Okay, so let me make it. Dataset. Okay, head, and it is showing only this part. Okay, so let me first of all change this intent. After that, look, here it is 5-day forecast, right? Current weather. Then it
Okay.
is coming 5-day forecast. So this is our Excel data.
Okay, fine. So we
Yeah,
have 26 records for current weather.
You know, it's just like 50. I'm just getting only 50 data. I'm
50
not.
data.
Yeah, it is not complete data set.
Okay.
Okay,
Fine.
so because it will take time to get all right.
Got
If you
got
want
it.
me to get the, you can get that.
No.
Do you want me to get all the records?
No. That's fine. That's fine. Yeah.
Okay, fine. So, any other doubts? Any questions?
Nope. I think we are good as of now.
Okay. So now after the training and evaluating the model, now the final steps come, which is our prediction of the model. So here, this I think I have already shown you. Suppose here I have written current weather. Now this model need to predict whether this current weather falls in which category. Okay. So hopefully I am asking about right now weather, current weather, right? So it will, the chances of this level, 50 current weather, hourly forecast is just 23%, and 5-day forecast I'm asking about is 70%. Suppose here I will write what's the weather after 5 days. Okay, what's the weather after 5 days or something. Okay, so as per the data available, the model training accuracy, it is showing that 39% chances that I am asking about next 5-day forecast. Okay. There are very less chances of 30% I'm asking about hourly forecast. 30% chances I'm asking about current weather. So it will tell you the probability basically. What's the probability of asking which label? It will fall under which category? It will tell you the probability.
Okay.
Yeah. So look how easy it is. I have written so much of code, right? So now there is no need to write this much code. Only these 3 endpoints. First is construct, train, and predict. That's it. It did all the work, right?
Because can you also reiterate some of the use cases that we can use this APIs?
The use case which you can use is for if whenever you are trying to make any NLP intelligence part for multi-class classifications, you can use this API. It depends. If you want to have this similar to weather or some other multi-class classifications you want to do, you can use this APIs.
Okay.
Yeah, but it is not like everything you can do with this API only. NLP doesn't provide everything like topic modeling and all that those capabilities. But yes, some of the capability it is having. You can use it.
Okay.
Right. So any doubt till NLP? So that after that we will move to computer vision part. And one more thing I want to add is, like NLP, this Einstein API trained its model and provided us the name of that model, right? So these are the data set we are providing, but it itself trained some model. Like for sentiment analysis, we can see they have provided us the name of the model. We just need to add a model ID as community sentiment. Like initially, if we see, right, here we are adding our ID. This model ID, we are adding our own, which the dataset on which we have trained the model. But they have internally inbuilt model IDs as well. Like community sentiment is a model ID, right? So it will tell us the sentiments, right? No need to even put your dataset, nothing you need to put. It is inbuilt. It is provided by the Einstein API. Like, I'm very excited. It is showing the label as 94%. I'm very positive. Neutral 0.03. Negative 0.02, right? So if I will write here, I'm very sad. Okay. So look how quickly it predict and how accurately it predict. There are very high chances, like 89%. I'm very feeling very sad while writing this, right? This sentiment of this text, you can say. Okay. The same.
So the next capability provided by Einstein API is our computer vision. So first of all, what is computer vision? It is driving the meaningful information from vision instead of language.
So that input can be anything. It can be, your images, your videos, or any other visual input. Okay. So the common example of this computer vision is your object detection, facial recognition. Autonomous vehicle is a very good example, because today we are going towards car, and without computer vision we cannot implement that. So that is also in medical fields. Also, we are using this computer vision with that image processing and all, X-ray and all. This is one of the example. Like this is the image. Here you can see that airplane, right? It is showing the accuracy of 99.4% that this is an airplane. This object read
is also detecting the humans in this. This all is the example of computer vision part.
Okay. So for this computer vision, as of now, I have not made the code for this, but we will go through but the processes will be same. Like, construction of dataset, then in pre-processing, instead of conversion of cleaning the data and all, we will do here the scaling of the images. After that, we can do image augmentation and all. So we will check it out, the endpoints. Let us go through the demo so that it will be more clear to you guys. So now these are the vision endpoints. You can see. Okay. So NLP, we are having here vision endpoint. The only thing is in language, it is lang over here. Now in right vision. Okay. So okay, let us upload the image. Here you will see I have uploaded the beaches image, mountain and beaches zip file. So what it will do is it will upload in somewhere in cloud, Salesforce cloud. It provided us this ID immediately. So the very first step is construction of dataset, which is done. After that, we need to train the model, pre-process the model. Pre-processing of the model involves image augmentation and all, scaling to some limit images so that it will provide good result. So what we need to do is we need to provide this ID. You can say here train a data set, right? Within data set. It is same algorithm, epochs and all we can give. So by default, it is taking like 20 epochs. So let us say here, this is the ID I'm giving here that my data belongs to this ID. So I just need to provide ID over here. So now it is showing queued, right? So we need to check its status, whether it's trained or not. So they have provided get training status endpoint for this. So there, I just need to mention this model ID. Okay, similar to language to detail because it is same. Here I need to provide here model ID and it is showing succeeded. Now your model is trained. Okay. So this is the epochs, 3 epochs. Learning rate is this. Learning rate we can tweak to get the more good performance. It can be 0.01, 0.03 or something like that. And after that, we can predict the image part. Our model is, yes.
Because so
Yeah.
is there a data limit when we are creating data sets?
Yes,
Because these are
there.
APIs, right?
Yes, there is a data limit. I think it is like 10, 20 MB something. 20 MB or if you are passing the path, then it is like 2 GB.
Okay, okay. So
Passing the URL, then it is 2 GB because from local you cannot import much data.
okay,
Path
okay,
is
okay.
look here. It is maximum is 2 GB if you will pass the path. Or data it is 50 MB from local drive.
Mm-hmm.
Okay.
Yeah. Okay.
So it is good to have this path because from local just 50 MB you won't get the good results.
Yeah, the
Okay.
vision part was really important. When you are going for maybe Twitter or somewhere, some your let's say product you want to see the reviews. Okay, so people generally upload the images.
Okay.
So in the vision part, what we can do is we can download those images, and from images, one example is like let's say you wanted to, if you pass the image, you wanted to see the result whether this fridge is two-door fridge or single door fridge. So then you need to model your train your model and upload this as much as possible images to the your model so that it will train it will try to
Ye-
understand which one
yes.
is the two-door fridge, which one is the first door
Ye-
fridge. So that
yes.
time I was facing this data issues where I was not
Uh-huh.
having. So then you need to actually, as you said, right? If you pass path, then you can leverage the 2 GB data,
Yes. Yes.
right?
And
Otherwise,
Ashish, one more thing. Like
Mhm.
you are doing this one fridge or a one door or two door part. There is one thing known as image augmentation, right?
Mhm.
So we can do image augment if so then it is very easy to do this image augmentation part. What we can do is like because it all depends on the data, right? So we can increase that data in memory by having image augmentation by vertical flap, horizontal flap the same image to different angles and all, so that in future whenever we will upload some new image it can easily predict that.
Yeah.
Yeah.
The first part which you explain on language, right? So
Mhm.
finding out like if somebody is writing reviews for your recipe or for your movies, so from that review comments you can find out the sentiment out of your. Yeah, that's
Right.
what the application. Yeah, I was working on one project where we need to find out, go to the Twitter or go to
Okay.
the review site, get all the reviews for that specific movie, and then find out whether
Oh.
it's a down or
Mhm.
up kind of thing.
Yes, yes,
Yeah,
yes,
I
yes,
got it. So,
yes.
yeah, its topic is vast. I know that, but if you give applications where they're using it, it will better to for our audience that they will get more out of it.
Okay. Mhm. Oh, So training status, we got it, right? Now our model is trained. So let us go for the prediction. Everything is ready. Now here, let us go and like our model is trained on beaches and mountains. So here, this is my mountain image. And here I just uploaded this mountain image and gave the model ID, right? Because we need to give the model ID, right? On which model we need to predict this. So look, now it is showing the probability that the image which we have uploaded is 99% falls under mountain and only 0.0003% there is a chances that it falls under beaches. Similarly, if we will upload any, like here I have uploaded beach image. Okay, look, there are little bit mountain looking at the back, right? Trees. So and it is showing like 99% it is beach and there are little chances that it falls under mountain, right?
Yeah. So because
Yeah.
here one more thing. So here there has to be one other category also, right? If you upload in random image, where it is going? Can you?
I will tell you. I will tell you. Actually, the thing is, it depends upon the data provided and the data on which model trained, right? So it is multi-class classification, or not multi-class. It is just binary classification. Either it will be a beach or mountain. So there is in dataset there is not provided the other third option, right? If the third option is provided only, then it will show. But if we will provide some other image, then it will lower its probability, maybe 0.003 for beaches as well, for mountain also 0.003. I'll tell you. Let us download some image.
Yeah. Yeah. So your data set has to have that, right? In my sense, like when you random image, if you upload it, then it should
Yeah,
go to, if it is not beach or if it is not mountain, it should go to third part.
yeah, no, not third part. It depends actually. It totally depends
Mm-hmm.
what you are downloading. It's like what
Mm-hmm.
labels you are having. If you don't have the third level, it won't go to the third level part, right? So let us download it here.
So Google Lenses are doing the similar kind of thing in the backend. If you take the
Mm,
image, it will go to all the sites and do the web crawling and try to
yes,
find out similar images.
yes. Look, here the chances got decreased, but it will show only this part only. It won't show the third part because the model, our training data, what we are providing is only these two labels. So it won't go to the third. It will decrease its chances, mountain and beaches chances.
Yeah, I got your point, Vikas. But
Mhm.
my point here is, let's say if you have logic to, take the topmost element from the array, right? So definitely you will pick up the mountain from here.
Mountain, yes.
Yeah, and you will say that that image belongs to mountain, but that is nowhere true, right?
But
That's
actually, okay, I will get you. Means like, but this logic we can implement on our side. Suppose we got this probability, right? This is a higher probability. Then we can set the threshold on our side. If probability is greater than 80% only, then we will consider it as mountain. Then otherwise, in MuleSoft database, we can write it that some other part.
exactly. Yeah.
Yes. So this is all about the Einstein API. So we can go here. Yeah, this is all about. It also provides some other endpoints like get a dataset, get all datasets from here, delete dataset. But the main part is only this thing, right? We need to create the data. We need to train the model. After that, we can predict the intent. Okay. So, guys, any questions? Hello, Anup. In chat, is there any questions?
No, Vikas. So this is the standard pattern, guys. Even I used one of this in my one POC where you need to have a lot of data. You need to train your model properly. While creating data set, you need to give the high quality data. Then only you need, if you wanted to identify it, you need to create a categories inside your mind and then map that. That's how your mind also works. So similar way here also vision as well as the language. So language is really helpful when you wanted to find out the sentiments behind your reviews and all that. So yeah, most of the companies are working on it and they are using this kind of APIs only. But the
Right.
data is very precious here. What kind of data you
Yes.
are passing to your while
Yes.
creating data sets.
Machine learning is all about data only, right? If we
Yes.
have quality data, we'll get good prediction. Otherwise, any model is waste, right?
Yeah.
So if you are thinking here, Anup, you want to go? Here
No,
MuleSoft
no.
is not doing anything. Yeah, it's just an integration part.
It is a MuleSoft is just an integration part, how we are calling that. But the only thing is we should have knowledge about whether in market Einstein API is there. So with MuleSoft we can integrate it.
Yeah.
Yep, and the more important part is the Salesforce. So they have given us the APIs where so many code is auto build inbuilt there. We just need to call that APIs and we should be good. So we can actually do what machine learning is about doing it, right, with APIs. Yep. So that's it. Let me take back present access. So Vikas, like, thank you for this man. So we got to know what Einstein APIs is and how it is working, and if you can provide us that links to us, so that will be also good. Sure. I'll get it from you.
Yes, sure. Thanks.
Yep. So let me share once again. Cool. So that's so we have one question before we move on. So can we mock the Einstein API behavior with Python mule module? Diraj, Vikas, can you answer that question, please?
Mock. I don't know about that. Sorry, mocking. I think we can do it on our. I don't know. No,
I mean,
I
can we
don't think
mimic the
so.
Einstein API behavior?
Maybe.
The same.
Okay. What I think he means to say is like he wants some API, and in that API you can have the complete implementation of machine learning code in the same way, right? Yeah,
Yeah.
that you can do. You can have yes, that you can do.
And
They should not be
which
issue.
language we need to use not to do that?
With Java also you can do that, right? With Java also you can implement this machine learning part as well
Okay.
as Python. Yeah. In Python, I need to check how we can do in MuleSoft, how to call the Python code. But in Java also you can write the machine learning parts.
Okay. Okay.
Yeah.
Fine. Fine. Yep. Any other questions, guys? We have enough time. Okay. So let's move on. So before moving on to our quizzes, like I just wanted to introduce what's the next we have. So next is I request you all to join our meetup group, Coimbatore meetup group, and support us. And most importantly, please provide your feedback. So feedbacks are one thing that we request everyone to provide, whether it is negative or positive. Please provide those feedback so that we can improve ourselves on that front. So please do provide our feedbacks at meetups@mulesoft.com. Cool. So, and the next meetup is going to be on September 25th, which is the custom dashboard, the some of the titanium features like logging, and custom metrics and functional monitoring and stuff. And Supriya Pawar and Sanjana Mishra is going to be our speaker. Okay, so it's time for the quiz. Yes, you are. So couple of things. Most importantly, you should not be a meetup leader in order to attend this quiz, and you should not have won any quizzes, trivia quizzes in the last 30 days in order to attend. So if you fall under these categories, please step back so that others get an opportunity to win it. Yeah. So there are certain instructions. So we are going to use Kahoot. So I think Balkis will be pitching in. So you can log into your mobile. Balkis, you want to give us direction how we should
Yeah.
go about it? Yeah.
Yes, right. So yeah, please everyone log in into kahoot.it. In your mobile, it will be helpful because in screen you will be seeing only the question and the option. In mobile, you will be getting the screen and the colors, which color you need to choose for that option. So please log in from your mobile, kahoot.it, and I will be sending you the game pin. So enter your game pin and give your proper name, not a nickname. Give proper name so that we can identify who won and who is in the top. So please provide your complete name.
Yeah.
So this is the
So
game pin you need to join. So, Amit, can you stop sharing?
yeah, I'll stop sharing. Can do you want to share?
Yes.
Sure. Yeah, stop sharing.
So, so you can see my screen here.
Yes, we can see your screen.
Yes, please join.
So we have 23 members. Hope we'll wait for a few more minutes.
Yes. Please let us know if anyone is facing any issue with connect with
Yeah. Yeah. So guys, you should be logging into from your mobile to kahoot.in and entering the pins 305064.
anyone want to join?
We have 11. I think we'll give 1 more minute to join. Yep. So guys, please take this opportunity. I think we have only few members, so that we have a great chance that you could win a training voucher.
Okay, let's start.
Yep. So let's lock it and start now. Okay.
The first question: Einstein API is used for. Five seconds.
Yep. Cool. So I think we have Nitish.
Ashish, Sunil, Cyber, Ashok. So the next question. Einstein API also provides an inbuilt trained model for sentiment analysis. True or false? So how fast you answer, you will get a chance to win. Please answer. This Ashish and Soumit on the call. We'll go for sentiment analysis model with input text. I am very happy text will provide the highest probability for which sentiment. Okay. This on fire, this actually side which is this example of a computer vision application. Self-driving car, face recognition, object detection, all of that. So again now. So the last question. Natural language processing can be used in which of the above option? Movie review sentiment, text generation, both A and B, none of them. Somin, congratulations.
Congratulations, Somi.
Ashish Chapman, congratulations.
Congratulations, Ashish. Nitish.
Congratulations, guys. Please
Congratulations, all
provide
the
your
winners.
email in the chat so we can send you a training voucher.
Yep. Congrats, guys. Congrats.
And if you don't have training account with those email IDs, please create it. Okay. Otherwise, you won't be able to get any vouchers for that. Okay.
Yes.
So make sure that